Imagine searching 1 million numbers and finding the answer in just 20 steps. Sounds impossible. That's exactly what binary search can do. Let's understand it step by step with simple example. Let's understand how binary search works using this example. Here we have sorted array of numbers, the values that starts from 10 to 91. Above the array, you can see the index that starts from 0 and going up to 9. These indexes helps us to identify the position of the each element. Now in binary search, we use three important pointers: left pointer, mid pointer, right pointer. The left pointer starts at the beginning of the array, which is index 0. The right pointer starts at the end of the array, which is index 9. Our goal is to search for the target value. In this example, it is 89. To begin the search, we first calculate the middle position of the current range, so that we use this formula, which is mid left plus right minus left divided by 2. Now we are going to substitute the value. Left is 0, right is 9. So the calculation becomes 0 plus 9 minus 0 divided by 2. This gives us the mid value is equals to 4. So the middle element of the array is at index 4. Before we start the binary search process, let's understand the main components used in this algorithm. Here we have sorted array of numbers. The value in this array starts at 2 and ends at 20. Binary search works only when the elements are arranged in sorted order, like this example. Now to perform binary search, we use three important pointers. The first is called low. The low pointer represents the starting position of the search range. It points to the first element in the array. The second pointer is called midpoint. The pointer represents the middle element of the current search range. Binary search always checks the middle elements first. The third pointer is called high. The high pointer represents the ending position of the search range. So during binary search process, we always keep track of these three positions of the beginning of the array, the middle of the array, and the end of the array. Using these three pointers, binary search decides which half of the array should be searched. Let's see a complete example of how binary search finds an element. Here we have an array called nums. The element in this array are -1 and ends at 12. You can also see the index position below the numbers. The index starts from 0 and goes up to 5. Notice that the array is arranged in ascending order. It starts from -1 and ends at 12, which is required for binary search. Now our goal is to find the target value, which is 9. Binary search starts dividing the array into two parts, the left part and the right part. After dividing, binary search starts dividing the array into two parts and focus on the middle element here, which is 9. Then the binary search checks the middle element of the smaller section. The middle value becomes 9. Since the middle value is equal to the target value, the element is found successfully. Finally, binary search returns the position of the target, which is 4. The index value, it always returns the index value. That is why the result is 4 here. Now let's understand the overall steps of the binary search algorithm. Binary search works by repeatedly reducing the search space until the element is found. The first step is initialize search bounds. Here we start the starting and ending points of the array. The start point represents the beginning of the array and the end points represents the last element, that is ending of the array. The second step is finding the midpoint. Here we calculate the middle index of this current search range. The midpoint helps us divide the array into two halves. The third step is compare the midpoint to target. Here we check whether the value at the midpoint is equal to the element we are searching for. If the target element is greater than the midpoint, we search it in the right half. If the target value is smaller, we search in the left half. The fourth step is repeat and process. Here we again calculate the midpoint for the new search range and compare it with the target value. Finally, the algorithm continues until the element is found or until the search element becomes. Now let's look at how binary search begins its first iteration. Here we have sorted array of the numbers. Starts from 1 and ends at 11. Below the array you can see the index position starting from 0 up to 6. At the beginning of the array, we define three important rules. The start index represents the beginning of the search range, which is 0. The end index represents the last position in the array, which is 6. Next, we calculate the mid index, which represents the middle element of the current range. In this example, the mid index becomes 3. If we look at the array, the element at index 3 is 6. So during the first iteration, binary search checks the middle element, which is 6, to compare it with the target value. This middle element helps the algorithm decide whether the search should continue on the left half of the array or the right half of the array. Let's start understand the efficiency of binary search algorithm using this cycle diagram. First we start with the double input size. This means the number of element in the data set increases. For example, the array might grow from 10 elements to 20 or even thousands of elements. Next come to additional comparison. Binary search performs one comparison with the middle element of the current search range to decide which of the array should be searched next. After that we see logarithmic growth. This means the number comparison does not increases rapidly. When input size grows instead of increases slowly because the algorithm keeps dividing the search space into halves. Finally, we have maintain efficiency. Even when the data set becomes very large, binary search still remains efficient because it keeps reducing the search range in every step. So this cycle explains why binary search has a time complexity of big O of log n and works very efficient. Let's look at a simple example to understand binary search. Here we have a set of numbers starting from 100 to 10. In binary search, the idea is to check the middle element of the list first, instead of checking every element one by one. In this diagram, the two middle numbers are 80 and 70s. The arrows around these two numbers indicate that the algorithm focuses on the middle part of the array first. Now here, binary search compares the middle value with the target value. Based on that comparison, the algorithm decides whether to search on the left side or on the right side of the array. This process continues repeatedly, checking the middle elements and narrowing the space until the required value is found. This is one of the core idea behind the binary search. Always focus on the middle and reduce. Now let's understand an important rule of the binary search. Binary search works correctly only when the array is sorted. Look at the first example here. The numbers are 2, 5, 3, 10, 4, 11 and 7. In this array, the value 10 is highlighted as the middle element. But if we observe the numbers carefully, they are not arranged in ascending order. For example, 5 is followed by 3 and 10 is followed by 4. Because the array is not sorted correctly, binary search cannot determine which side of the array should be searched next. Now let us look at the second example below. Here the number starts from 5, 1, 3, 8, 4, 25 and 7. The middle element highlighted here is 25. Again the numbers are not arranged in order. So the algorithm cannot decide whether the target value is on the left side of the array or on the right side of the array. This is why sorting the array is a necessary condition before applying binary search. Let's understand the complete working process of the binary search algorithm using this flowchart. The algorithm starts by initializing two variables. First we set left is equals to 0, which represents the first index of the array. Next we set right equal to array length minus 1, which represents the last index of the array. After setting these boundaries, we check the condition left less than or equal to right. This condition ensures the search space is still valid. If this condition becomes false, it means the element does not exist in the array and the algorithm returns minus 1. If the condition is true, we calculate the middle index using this formula. Mid equals to floor of length plus right divided by 2. Now we compare the value at array mid with the target value. If the array mid is equal to the target value, the element is found and the algorithm returns the mid index. If array mid is less than the target value, the search continues on the right half, so we update left is equals to mid plus 1. Otherwise, the search continues on the left half and we update right is equals to mid. Now let's see a complete example of binary search in action. Here we have a sorted array 9, 17, 25, 34 and 49. The position of these elements are shown below as index value 0 to 4. Our goal is to search for the element k is equals to 34. First binary search identifies the middle element of the array, which is 25. Now the algorithm compares the middle element with the target value. Since 25 is less than 34, the target cannot be in the left half of the array. So the search range is updated and the algorithm focuses on the right half of the array. Next, the middle element is calculated again within the smaller range. Now the middle value becomes 34. Since a mid less equals the target value, the element is found. Therefore, binary search returns position of the element, which is index 3. So the result